For example 3, we want to multiply out these binomials. And since we have times and plus, we have to make sure that we distribute our multiplication across the times and the the plus and the minus. So we start with our 2x. We're going to do the first times first. So 2 times x is 2x squared. We do the outside. So 2 times 5y, so 2x times 5y gives us 10xy. And then we do our inside, so minus 7xy. And then last, so negative 7 times positive 5 is negative 35. And then we get y times y, or y squared. Now we combine the like terms. The middle terms tend to be like terms, so we end up with 2x squared plus 3xy minus 35y squared. In part B, the one thing we never do is square when there's pluses or minuses. Okay, so this is wrong. We never do this. 9x squared minus 5 squared. Okay, so that would be always wrong. Okay, big bad. What we need to do is, if we want to multiply out a square, we have to do it as multiplication. We can't mix squares and pluses and minuses. So we have to rewrite this as multiplication. And now we can distribute. So first, 9x squared, outside, negative 15x, inside, and then last, negative 5 times negative 5 is positive 25. Again, the middle terms are like terms, so we combine the like terms into 30x and then plus 25. So factoring is going to be the opposite of multiplying. So we're going to rewrite this as factors that multiply to each other. To do this, we're looking for two numbers that multiply to 20, and they're going to add to the plus 8. Okay, so numbers that multiply to negative 20 are going to be 10 times 2. They have a difference of 8, so then we can use those as our factors. So we get x plus 10 times x minus 2, and that is a factored form of that quadratic. Again, if you want to check this, we can check this by expanding and combining like terms. When we do ones like this, we always check for greatest common factor. So in this case here, there's a number in front, so we check to see if there's common factors. In this case, there's no greatest common factor, so we have to use the quadratic factoring where we multiply the first and the last. So I've done this here in the grid. So I'm going to multiply 3x squared times negative 10. That gives me negative 30x squared. Now how we use that negative 30 is that we're looking for two numbers that multiply to the negative 30 and have a difference of 13. So the numbers I'm thinking of are 15 times 2. So we're going to have positive 15, negative 2. And then we can work out our factors by looking for common factors along here. So between 3x and 15x, we have a common factor of 3x. Between negative 2 and negative 10, between negative 2 and negative 10, we have a common factor of negative 2. So we're going to end up with 3x minus 2 as one factor or one side length. Here the common factor is going to be just 1x. The common factor here is going to be a 5. So we end up with x plus 5, 3x minus 2. Okay, and it looks like that negative is hidden here, but that's a negative 10 in there. For part C, it's important to recognize that we have a common factor in all three terms, and you have to factor that first. So we're going to factor that greatest common factor of 3 out first. And we're going to make sure we show it with multiplication. Once I've factored that common factor out, now I can look in the brackets and ask, since there's no number in front of the x squared, I'm looking for two numbers that multiply to 6 and add to 5. And we have to make sure we keep that 3. We don't forget about that 3. So two numbers that multiply to 6 are 3 and 2, and they add to 5. So this is factorable. For D, this one here, we look again for greatest common factor. In this case, there's no greatest common factor. So we have to multiply the first and last, which I've done down here. And we get 30 times negative 15, which is negative 450. Okay, so this one here is more challenging because there's lots of different numbers that multiply to 450. But we're looking for ones that have a difference of 7. Okay, so they have to be relatively close together. So in this case here, if we try, 15 times 30, okay, that there's 15 apart. We can try 18 times 25. Well, 18 and 25 happen to be 7 apart. So that's what we're looking for. We're going to look for negative 25 times positive 18. That's going to give us the 450 that we want, and it adds to negative 7. This is what we're looking for. We can factor common factors out. So there's a common factor of 5 here. There's a common factor of 3 here. And I don't factor the negative out along the horizontal. I'm going to factor the negative this way because those share a negative 5. So it's going to be minus 5. And then we have a common 6 here. So we have 6x. And everything is consistent. Okay, 6 times 5 is 30. 5 times 5 is 25. 6 times 3 is 18. Negative 5 times 3 is the negative 15. So we have the right parts. So this must be the factors. 6x minus 5 times 5x plus 3.